Okay, good day, my people. Welcome to today's topic, which is learning Python with data science day 16. And in today's topic, I'm going to tell you the amazing thing that NumPy can do that you guys never believed that it could do, right? It's a very fun topic, and basically, I always love fun, right? I will never be in a place that those topics are not fun, right? So, in today's topic, I'm going to be diving deep. I'm going to tell you the things and how NumPy is being used. And some of you, if NumPy is new to you guys, like I said, welcome to analysis in general. In our other classes, I've just been introducing you guys to Python, and now is the main thing for data analytics, right? We're going to be talking about the toolkits that basically we're going to be using. We're going to talk about NumPy, pandas, and so many other more libraries that we have in Python that is going to help us in our data analytics skill. Okay, so make sure you stay tuned, make sure you follow, make sure you subscribe. If you're new here, you've been following us from day one, please subscribe. And if you know any other person that loves analysis in general, any type of analysis, if it's a trader, whatever, and the person is looking for another type of skill, like I always say, make sure you refer them here, bro. Make sure you share this thing to them so that basically we can see all the analysis they can basically do. There are many amazing things that we can do here. But apart from that, subscribe, stay tuned, and let's dive deep into it. NumPy is like a super efficient toolkit for handling and processing numbers, which makes your data analysis faster and simpler. That is one of the toolkits in data analysis. So NumPy is basically, we use it for numbers, like handling numbers, and it makes it super efficient, especially when we want to, perform things like visualization. NumPy is always there. Number one reason of why NumPy is amazing is it handles data like spreadsheet. NumPy helps you to store and organize numbers, rows and columns, just like an Excel sheet, but it's way faster. It handles data like spreadsheets. In your Excel, you can see rows and columns. That is when NumPy comes to play a role. It makes it easier. Just a little line of code, boom. My columns and my rows are arranged in a simple form, and it gives you that good spreadsheet. In fact, if you see the spreadsheet, you'll be like, wow, I can't believe this is happening, in Python as well, right? That is one of the amazing things that NumPy can do. Second, it does math super fast. Like, some of us are not fan of math, but I think when I was in school, I was good at math. Yes, I was good at math. Trust me, like, I was good. But for some of you who are not good at math, that is why basically you're scared of numbers and you're like, can I even learn this data analytics? Can I even do anything here? Like, math is involved, all this technical stuff is involved. No, NumPy got you covered. Imagine you want to add, subtract, or multiply hundreds of numbers. Doing it manually would take forever. NumPy can do it in seconds for thousands or even millions of numbers. Can you see that? So adding, subtracting numbers, even in Excel can be so slow, but over here in NumPy can do it in seconds, and it does not even depend on the numbers. It can be thousands, it can be millions. You understand? And it keeps on going like that. In a second, it's done performing the subtraction, multiplication, whatever thing you want it to do for you. That is one advantage of why NumPy is amazing. Third thing why NumPy is amazing, NumPy can quickly calculate things like averages, total, or pattern in your data. For example, if you have a list of sales numbers, it can tell you the average sales. So if you have a sales numbers in your data, you can basically use a particular code that will basically give you the average sales in that particular area. Fourth thing why NumPy is amazing, data cleanup. Let's say if your data is messy, like missing values or weird outliers, NumPy helps organize it and prepare it for analysis. Some of us, if you go to our data, you see that there are some missing rows, there are some outliers, unnecessary things that are not meant to be in those data. So you can basically write a code that basically will organize that data and prepare it for analysis. That is the fourth thing why NumPy is amazing. The fifth thing is speed up comparison, in the sense that, let's say you want to find which customer spent more than $100, NumPy can instantly compare each value and tell you who they are. One of the reasons why NumPy is good, it helps in comparison. The customers that spend more than $100 in a particular business, when you write some certain code, NumPy will go through that data set and pick out those certain numbers or those certain customers that spend more than $100. If you want to create charts or graphs using other tools, NumPy arranges your data in a way those tools can simply or easily read. Those are the 5 reasons why NumPy is amazing. And some of you are already eager to say, wow, I would like to see this NumPy. I would like to see how it works. So I'm going to be diving straight to my PC right now. I'm going to basically show you how basically we use NumPy and how we implement it in Python, right? So I'll just show you some few stuff, and from there we build up on it. Okay, so stay tuned. We are here now in our VS Code. This is our VS Code environment. I have a video on this particular setup on how we got to this place. So if you've not watched the video, click on the link above and basically go there and watch the video so that you can join us in this class. Okay, so in the last class, I think we stopped there. So the next thing we're going to do is going to open our folder. And if you don't know how to open your folder, go to this particular file, then click on open folder, right? It's going to show you your folder name, then click on it, then you're going to have all your files here, like from the day 1 to the last day. You can see everything. Why you're not seeing day 14 is because day 14 we basically did installing of VS Code. Day 16 is today, which is NumPy, the amazing things NumPy can do, right? So now I will basically jump straight down to that particular thing. So I'll click on this file, then I'm going to now write the necessary thing. So today is day 16, which is NumPy, numpy.ipymb. So ipymb is the extension name that we're going to be using over here in VS Code. Whenever you want to use a particular file, you have to add the extension name to the end. If it's python.py, if it's jupyter.ipymb, because those are the things. They are different type of softwares, right? Like I said from the beginning. So you hit enter, creates the file, then we're here, right? So let's go straight to it. We're going to create a markdown. So you just click on this addition, it brings out the markdown environment, and we use this hash and we say numpy, and over in the numpy we run this particular code and we have the numpy there. So the first thing I basically want to do, I want to introduce you guys to, so we're going to import the model that we need for this particular software. So we have to say import numpy as NP. For some of you, you may not have NumPy, it may give you issue later on. So just do Ctrl J, it's going to bring out this terminal for you. Make sure it's on terminal level. Then I want you to say pip install NumPy. So hit enter. So it's going to use your internet, like the last one, it's going to use your internet to basically install this library for you. Okay, so it's done over here. The next thing we're going to do is to come back here and run it. So it's going to ask you to choose your Python environment. Click on this, then you choose this particular base Python. So it's done. As you can see, we already have our library installed. Like I said, I'm going to take you guys from step to step, like how everything is being done. So NumPy is installed already, and that's why this particular code is checked. If yours is having issue, make sure that you install the necessary package, which is pip install numpy. If not, it's not going to work at all. Okay, now I can now basically use this package. I already installed the toolkit, it's already in my environment. Now it's time for me to basically implement it and see how we can work with it as well. Okay, so the first thing is creating an array in NumPy. So if I come here now, I basically want to see how NumPy are being arranged. They are arranged in arrays, and arrays are homogeneous numbers. That means they must be of the same length and of the same character. Do you follow what I'm saying? So whenever you're bringing them in, they must be of the same length and the same numbers must be inside of them. So let's create our first array. So we'll say array 1, and array 1 will contain these numbers, series of numbers inside of it. So we're not going to call the np.array. So it's going to now convert this particular thing to array for us. And so some of you will be like, oh, this kind of look like list when we did list in our previous classes, right? This is not like list, but it's also used to save or store multiple elements inside of it. So we're going to now create numbers, right? So we're going to put like 10, 100, 90, 95, 120, 150 inside. So these are all the arrays that we want. So if I come here and I say array 1 and I run this, you can see an error there is object is not subscribable. So it's kind of a type error. We have to put a parenthesis at the beginning and at the end. So when we run this, you can see it brings out everything in an array form. Okay, so basically just created our first our first array. That is one of the uses of NumPy, right? It helps to create numbers, like helps arrange numbers for you. Another one that we have over here in the array while using NumPy is the dimensions, like the dimensions that we have. Like what are the dimensions that we use in the NumPy? So I'm going to create like 2 dimensions and we're going to see what we're going to do from there. So we'll say np dot array, then over there we will have this box. So these are all the arrays that we have in this NumPy. How do I basically use them and how do I basically find out this array? Okay, so what I'm going to do is to say array2 dot ndim. Ndim is basically going to give me the number of arrays that I have. So if I run it, whenever you're creating your 2-dimension array, that's why we're having this error, is that you have to add another bracket here. So we add 1 there and we add 1 at the back here. So we now have 2 dimensions. How do I know? By looking at these 2, I know that's the 2 dimensions. So when I run it, you can see it's 2-dimension array. So another importance of NumPy is arranging numbers from a certain level to another level, right? So I can say array3 should be np dot arrange, and in arrange I will have from 1 to 50. Then I'll come here and I'll say array3 and I run this. When I run it, you can see how it looks like. It starts from 1 to 50. Now I can basically say I want to be adding each of these in the 3 sequence before the 50. So all I just have to do is say 3 at the back and I close this. If I run it, you can see 1 adds 3 using 4, adds 3 gives 7, adds 3 gives 10, like that. So you can see how basically arrange it with sequence of 3. So instead of from 1 to 50, normally it just adds 3 sequence before it goes to the next number. Okay, another one that we have is NumPy helps to create random numbers, like starting from a particular random number to another type of random number. Like I can arrange a series of numbers in random. That means I can have different random numbers inside of a NumPy. Let's say array 4. I'm going to say np random dot randint. So we have this over there. So I basically wanted to choose from, let's say 10 to, let's say 100. So if I want to see 100 inclusive, I have to basically add 1. If I don't want to see the 100, I will basically have to stop at 100. So 100 will be exclusive. It's not going to be added to the sequence, right? So but if I run this particular code right now, I'm just only going to be seeing random numbers, right? So 58, can you see that, 40, 61, just random numbers, right? 90 and stuff like that. But now let's say I want to see this number, let's say in 50 places or 20 places. I can basically come here and say 50 at the back. So if I run this, you can see we now have random numbers from 10 to 100 in 50 places. That is one beautiful thing about NumPy, right? So anytime I run this particular code, I'm going to see a sequence of change number from the starting number to the ending number that I chose. But you can see 100 is not inclusive. So if I want 100 to be inclusive, I add 101. Can you see? If I keep running this, can you see 100 is found inside of the sequence now? Okay, so what if I don't want to be seeing these numbers changing over and over? I just want it to be stagnant. I just want it to be at one place. What can I do? That is where I'm going to use something inside of the NumPy toolkit. So it's known as seed. So I'll say np.random.seed. So .seed, inside of it, I'll add 1. So if I add 1, I run it. So this number, no matter how many times I run it, it still give me exact the same number. But before, you can see when I keep running it keep changing and tweaking and stuff like that. Another thing our NumPy has is reshape. So let's say this random number now, instead of 50 places, I want it to be in 100. So I run this. You can see we have this in 100 places, but you can see how it looks like, right? It looks all messy. I can use certain toolkits inside of NumPy to basically reshape this particular thing. Let's say I don't like the columns the way they are arranged. I want to basically, give it a structured kind of a table. I can basically come to this next line. I will come to array 5. Then array 5, I will call array 4 dot reshape. Then in reshape, instead of me just leaving it this way, I have 100, right? So for me to get 100, I have to be basically constructive. I have to know what I am doing. I have to basically mind the thing that I'm doing. Yeah, I have to be careful, right? So I can't just basically reshape it to any size. Let's try it. Like, always take the first number you put as the row, then the second number as the column. So let's say I want it to be in 10 rows and 2 columns. So if you run this, you can see cannot reshape array of size 100 into the shape of 10 to 2. So now you have to basically be constructive. So 100 can be reshaped into 10 by 10. That is 10 times 10 will give you 100. And it can also be reshaped to 50 by 2. 50 times 2 will give you 100 as well. So if I want to reshape this particular thing to 10 now, all I just have to do is to give it 10 rows and 10 columns. When I run this, exactly, if I come here and say array 5, I run it, you can see it's now reshaped to 10 rows and 10 columns. It's as simple as that. You remember one thing that our data said, the customers that pay $100 to your company, and you want to basically find out how do you do that. So we use this NumPy to basically do that. And now I'm going to basically implement it to show you how it's been done. Let's say I'm looking for numbers that are greater than 50. I want it to only display that. So I'll come here and I'll say array 5. Then inside of bracket, I will say array 5 greater than 50. And I run this. And you see, it only gives me numbers greater than 50. The same thing for less. So if I copy this and I paste it here and I change this one less than 50, I run it, you can see there's no one that's going to be less than 50 here. And let's say exactly the amount that I'm looking for. All I just have to do is to say equals to 50 and I run it. So equals to 50, you can see the array is empty, right? So that means there is no number. If you check this data set, there is no number that 50 is being found there. So there's no number at all. That's why it's giving me empty. But let me say equals to 35, because I can see 35 there. You can see we have like 435 there. So let's say I have this to array. A should be array. Then each contain series of 9, 900, 5. Then we have B, and B should contain. So we have to make sure that they are homogeneous, of the same length. Okay. So now the next thing I can do now, I can multiply these two variables, which is A and B, in a quick, easy way, right? Let me say add. Say add A plus B. So A plus B, if you call add, run it, you can see it sum up each of this particular one together, right? So much more, I can also do multi for multiply. Then I will say A multiply by B. So if I come down here and I say multi and I run it, you can see it multiplies each of this particular one, so on and so forth. So in the next class, we're going to continue. I think we're going to be going into pandas and stuff like that. So make sure you stay tuned. If you enjoyed this class so far, make sure you hit on the like button. And if you're new here, you just the first time coming across Blue Goes Inside, seriously, you've been missing a lot. Okay, so you can go through other videos as well and see what we do, and you can see that we basically analyze a lot of stuff over here, and we try to drive insight, and our education is top notch. That's why basically you can see how fast we're growing. So make sure you come here, make sure that you want to equip yourself, you want to basically know more about data analysis and so on. So this is the place meant for you. Subscribe, belong to the family, and you will gain more things from this channel. Okay, so that will be all. Make sure you stay safe and you stay profitable as always. Have a nice day.